There must be some kind of way out of here, said the joker to the thief. There's too much confusion, I can't get no relief. Businessman there.
Hello, everybody. Today I have a very interesting guest, Stormy BOUDREAUX, and he's probably the fastest man that I've ever met. Now, correct me if I'm wrong here, but the plane that you flew, the SR-71, could fly 3,200 feet per second, and in layman's terms, that's 9 football fields, or 5 times the speed of sound. So I'm looking forward to talking to you about this.
Did you say 5 times the speed of sound? It's 3
5.
times.
3.
Oh, 3 times the speed of sound.
Google was wrong.
Yeah.
Just to give the people a better understanding of how fast that is at Mach 3.3, right?
Right.
That an average jetliner is flying at 560 miles per hour. So that was for a 737, it said, and flying at an average altitude of 31 to 38,000 feet, where when you were flying the SR-71, it says that it would be upwards to 80,000 feet. Is that correct?
That's right. What we used to say is that when we would see an airliner and look down at it and go, I'm higher above that airliner than that airliner is above the surface of the earth.
So for the people watching who don't have any idea of what the SR-71 is, I was actually lucky enough that as a kid, I saw one at a local air show here. And as a teenager, I had the poster on the wall, the Blackbird, and
Yep.
It's just kind of fascinating. And even back then, and you can educate all of us a bit later, that when you're flying at that speed, that the plane is actually expanding in both length and width. So that's what, and the airspeed that you're flying at, when that hits the actual airplane, the temperatures that raise are just phenomenal. So could you tell us all a little bit about that? I've talked for enough.
First of all, in order to try to, when I give talks to youngsters and to other people, I've struggled sometimes to try to give them an idea as to how to have a concept of this speed, because the human mind doesn't really, and particularly a child's mind doesn't really. So here's what I came up with. Most of us live where we have, in the United States, an interstate highway, or you have a dual carriageway type environment that the speed limits are relatively elevated. They may be 120 to 130 kilometers per hour, or 70 to 80 miles an hour. And you get used to, all right, if you're driving 60 miles an hour, you go 1 mile in a minute. And so if you're on one of these highways, and there are a few sections of them where they're relatively straight, and the roads, when they cross them, don't just drive across them. They sometimes build a little bridge so that the bridge goes over the top of it, and so the traffic doesn't run into each other. And so I tell the children, if your dad is driving in this car, your mom's driving the car, and you see that there's a exit coming up, and the sign says exit 1 mile, and you can look up in front of you because the way the road is, you can see that bridge 1 mile in front of you, and you think about how long it's going to take you riding your folks' car to get to that bridge. And if you just were to go and say, at the moment you cross that 1 mile, and say 1 potato, 2 potato, and before you can get the second full potato out, you've now crossed the bridge if you're flying at 3,200 feet per second, or at Mach 3.2. And it's a mind-boggling thing, because when you think about that, you and I are sitting in a car and we're looking out that way, and you just go 1 potato, 2 potato, and you feel like you've hardly gone from the beginning of the exit to the end of the exit at the speed you're going, and yet you're going to go all the way to where that bridge is. And so And what is amazing, when the rifle, and they used a 30-06, which is a typical deer hunting rifle of the day, and it has a muzzle velocity of 3,000 feet per second. So we used to always say that we were flying faster than a speeding bullet. It's a good rifle. It's not a particularly slow rifle. It's a particularly fast bullet that comes out. And when we say we're flying faster than that at 3,200 versus 3,000 or 3,000, that's pretty impressive. But even more so when you say, when that bullet comes out of the rifle, it starts slowing down immediately. It's going that fast at the moment it comes out of the muzzle, but as it's hitting the air, it's slowing down, slowing down. So it takes nearly 3 and a little bit seconds to reach a mile, whereas the SR-71 is maintaining that speed for approximately an hour.
Wow.
So that's why they were able to set a record of being able to fly from the west coast of the United States to the east coast of the United States in about an hour and 6 minutes, because they could sustain that. And when we fly across, say, from the west coast all the way to England, which is about double that distance, it takes longer than that, because at about the hour point, we have to slow down, hook up with another airplane, refuel, and then climb and accelerate back up again. But I can fly from California area to land in England, but go by the northern part of Russia before I turn and go back. In other words, take a little side trip and land in England in 3 hours, whereas it takes 5 hours for an airliner just to cross the United States, from West Coast to the East Coast. So speed is something. Being able to sustain the speed is even more awesome in my mind. And I think I've gotten off on the speed so much that I've missed being able to tie together the other parts of your question.
No, I was amazed at this because, and you just kind of covered it, that what was slowing the bullet down when it left the barrel was air. Now, for your average person, air, we would think, unless that you've just done school and physics exam, air does have weight. But when you're pushing your airplane at that speed through the air, I read that the temperature on your glass, on your cockpit glass, was like 600 degrees or something Fahrenheit.
600 degrees. It was about the pie in front of the airplane, the little pie-shaped windows were in the 400-degree centigrade numbers. So these are 600 to 700 degrees Fahrenheit. They're very warm. Some of the other leading edges can get that hot or hotter. The side windows are technically a triple pane. 2 of the panes are so close together that they consider that just one. There's a very slight gap in it. Then there's a small space, and then the inner one is. So it's like a really good window that you'd have in your house that you're insulating from cold weather. And yet, when we're flying, if I took my hand and I put it up the back of my hand against the window, I could do it once again, that 1 potato, 2 potato thing. I could hold it up there for about 2 potatoes, and then I'm taking my hand away and I'm trying to bend my hand down because the glove is so hot that it's burning the back of my hand, and I'm trying to get my hand away from the glove while it's inside of there. So you can't put things up there or spend a lot of time but when we fly at 70 and 80,000 feet, there are less molecules to run into of air than they are down at sea level or lower altitudes. And so the bullet actually has a tougher time because it's pushing through thicker air. But both the bullet and the SR heats up, and all airplanes technically heat up just a little bit But until you go supersonic, until you go over 700 miles an hour, the heat is not that substantial or nearly worth worrying about. But when you start going 3 times the speed of sound, now the heat becomes a problem because all other airplanes are made out of aluminum or aluminium, depending on which country you're from and how you want to pronounce that word. And that tends to, at the 600 degree 600 degree centigrade temperatures, to start to turn plastic and start to lose its rigidity and start to stretch and sometimes not be able to return back to the shape that it was. It's melting, but in coarse figures. And so they made the airplane, the SR-71, out of titanium, which resists melting so much more, but it's also a very lightweight, and it's nearly as strong, or it's as strong as steel, but lighter than steel, so that uh, it's capable of resisting the temperature that the airplane was being thrown through, but also because you could have done it with steel, but steel would be so heavy that the airplane wouldn't fly, or it only flew for a couple of 100 miles for it to have to land. So it's really an amazing airplane because they had to use different materials to make it out of. And that becomes another story, because in order to have enough titanium to build the airplane, the United States didn't have access to that much titanium. But another country did. And that country, the United States, set up some fake companies to purchase the titanium from. And so they purchased it, and they were sent to these bogus companies, who then sent it over to Lockheed, who then processed it and made it into sheets of titanium and billets of titanium and forgings of titanium. Even today, the landing gear on the SR-71, the forging of it's a titanium landing gear, and it's the largest forging of titanium that's ever been accomplished in the world. Not just something that the largest in 1959 or 1960, but the largest ever. But the interesting thing about it is that country that the titanium came from was Russia. And so Russia didn't know that they were selling titanium for an airplane that was then going to go presumably look at them by the basis of having this wonderful material to be able to have. I usually have, yeah, here, this, I don't know if you can see
Yeah, it's a
this.
bolt. Wow. Yeah.
It's a bolt. And you would think it's about 5/8 of an inch in diameter and about 3 3/4 to 4 inches long. And I wish I could hand it to you so you could feel it. It
Here,
is,
I'll grab it.
yeah, there you
Grab
go.
it.
You almost feel like it's made out of plastic and hollow,
Wow.
because it is so light. Obviously it does have weight. It falls, it doesn't float. But compared to what this bolt would look like or feel like if it was identical but made out of typical steel that you'd have, I mean, this is the kind of bolt that you might have in the front end of a truck to help
Yeah.
hold the wheels together, the suspension together. And that would probably be, I don't know, 600 or 700 grams worth of material, or just heavy. And this is very, very light.
So now that we've talked about the actual plane itself, I guess that we should talk about what that, number one, because the plane came out, it was called the Skunk Works, right? So that was kind of your special, projects group. But more importantly, can we talk about what that plane was made for and where men that flew it, like yourself, would be flying?
So after World War II, the nations of the world sort of divided up into uh, different countries that were, some were grouped together and some were opposing that. And it looked like one group looked like they wanted to take over more of the world, and we were concerned about maybe they would build bombers and they would come and bomb the people in North America. And so we wanted to see, do they really have a lot of bombers? Do they really have these things that we think they might have? And so the United States tried to get a open skies policy to where we would fly over Russia, which was one of the opposing countries, and they could fly over our country. But the leaders in Russia said, no, we don't want you doing that. And so they decided that they were going to go around that and just fly over them at such an altitude that they couldn't do anything about it. So they built an airplane called a U-2, which is a powered glider, very powerful engine in a very lightweight airplane. Take it up high enough. And here's where they ran into trouble, because when you start to think that you know more than anybody else, the United States realized that if the U-2 flew at 70 or 1,000 feet or above, our radars couldn't detect it. So we went, oh, great. We'll fly this over Russia and be able to look down with cameras. And that was another project they had to do, was build really good cameras to take good pictures from that far away. Because that's, when you go 70,000 feet, that's really like 15 miles above the surface. So you got to have a camera that takes a picture 15 miles away with enough detail to be able to figure out what's going on, instead of just, oh, there's a peninsula sticking out into a lake. You wanted to actually see what was there. But here's where they ran into problems, because the Russians' radars were better and they were able to detect the U-2 when the United States' radars couldn't. And they were smug, thinking, oh, we've got something they'll never see. But they did. And so very early on, they realized, okay, the Soviets at that time, that's the area is Russia plus the rest of its dominion around
yeah,
it, satellite countries,
yeah.
were developing anti-aircraft missiles. There was no anti-aircraft guns that could reach that high, but they were developing missiles, and so far they couldn't get there, but they knew that they would get there eventually. And so even before, and so we were flying U-2s over the top of Russia, and we were collecting a lot of information. And we've realized that there was what was called a bomber gap, that when we had somebody watching the May Day parade and see bombers flying overhead and go, that's thousands of bombers. Later on, we realized that what they were doing was flying the same group out of sight, making a circle, come back around. But if you start counting them, you're counting them 4 or 5 times. But later on, when they were flying the U-2 over the top of them, they realized, oh, they only had 50 or 60 of them. They didn't have thousands of them like we thought they did. So that's one of the reasons why the United States was able to build its interstate highway system, because instead of putting so much money into the Defense Department, there was, okay, we have this much money from however nations build money, and we can build different things. And so instead of having to build an enormous bomber fleet, we can build a bomber fleet, but we don't have to go terribly overboard with it. We can do some other things that are socially redeeming for the nation as well, and build the interstate system. So President Eisenhower is given the credit for, in the late 50s, early 60s, of developing the interstate system, which he had seen in Germany and admired that.
Autobahn. Yeah.
Yes, and to build something similar to that, and we didn't have to go through that, but we were still concerned, because it wasn't shortly after that that the Soviets started building rockets, and now we were concerned, okay, are they going to go into space and stuff? So by the late 50s, 58, 57, 58, they knew that the U-2 was vulnerable and could be shot down. So they started working on the follow-on to it, which eventually became the SR-71. But so they started working on a higher speed, higher altitude airplane to replace the U-2, and they kept flying the U-2 over until, unfortunately, on May 1st of 1960, one of our pilots was overflying the Soviet Union, and he did get shot down, captured, was put on trial. It was very embarrassing to the president, and different things went on. This is a whole nother book. It's worth talking. But
Mr. Powers, right? Gary
Gary Powers,
Powers. Yeah.
right. And so, but the SR-71 was almost actually the predecessor to the SR-71. It's an airplane that very few people know about, and it was kept even from the people who flew the SR-71 till the late 80s to have anybody know about it. It was called the A-12, which was a single seat version that was ever so slightly shorter, had a little bit less fuel in it, used the same engines. Most people look at it and go, well, that's an SR-71 because it looks the same. But it's actually a little bit smaller. It only carried a camera right behind the pilot, didn't have anybody else to operate any other things. And its main purpose was to take pictures, and it was going to fly over Russia. Well, when Gary Powers got shot down, and the whole political fallout from that was that President Eisenhower promised that the Russians that we would never overfly Russia again. And so he meant that. And so even though the A-12 and then the SR-71 was built primarily to overfly Russia from the beginning, it ultimately became a peripheral mission rather than an overflight mission. So all of the missions I ever flew that I went close to the Soviet Union, I never got closer than 12 miles to it. We would fly that close, but not closer, never did overfly. Now, there were other places that we have overflown. We overflew Cuba quite often. We overflew some other locations. Nicaragua was one when they were worried about what was going on there and they wanted some information. Some of the other countries in the Southeast Asia area, they overflew. But flying over Russia was forbidden, and it didn't happen. And this is not I'm telling you one thing and really not saying everything else. This is the truth. We didn't overfly Russia after the Gary Powers incident.
All right. So that's just so much information, right? And so just to take a step back, because a pilot does not simply enter into the SR-71 program. So when I looked at your bio, which is on your website, which I will post at the end of the video, the T-38 and the T-33, they were both jet trainers, right?
Correct.
Okay, but the F-4 would be your first fighter jet, proper fighter jet that you flew. Now,
that's correct.
Did you fly that in Vietnam, or were you?
Yes, I had 658 hours of combat time in a year in Vietnam. I flew out of Da Nang Air Base, which was right in South Vietnam,
Yep.
and we flew missions up and down the at that time, sometimes people refer to it as the Indochina Peninsula, but the South and North Vietnam, Laos, Cambodia, that general area there. And there were other bases in Thailand. And quite often, if we would have, if we ever had a malfunction and the opportunity presented itself to where, oh, I need to land the airplane right away. And there was a choice between, do I go back and land at Da Nang or do I go over to Thailand and land? There was never really a choice there. We went to Thailand because it was much, people were not shooting at you there or attempting to throw a hand grenade into the vehicle you were with and stuff. Whereas that was a nicer, if you've got to be away from home, that was a nicer place to be than being inside of Vietnam itself. But that's what I did. And I did two things of note. Not only was I flying the regular missions, but I flew what was a totally voluntary unit called the Fast Facts, and its call sign happened to be Stormy. At the same time, my call sign was Stormy, so the guys started calling me Stormy Squared while I was flying there. But what we were doing was flying as forward observers, looking for things that the fighter bombers could bomb or to interdict. And we were flying where the slow movers, the O1, the O2, the OV-10, were in peril. They couldn't fly there because there was too much defense. So we would fly there. And it shows in that how many times I had bullet holes in my airplane during that period. And so coming back to land 21 different times with bullet holes in your airplane is not necessarily a good thing to brag about. It's just a fact that we were in a more hazardous area and exposed ourselves to hazards in order to be able to do that particular mission, which was a very effective mission in places to try and stop what was called the Ho Chi Minh Trail, or the jungle highway that would come down to feed the
Groups, yeah.
the Viet
NBA,
Cong
yeah.
in the South Vietnam.
You know, a lot of my special forces friends, they were dropped off in Laos, you know, in Cambodia, you know, in their recon teams, and they said that the Ho Chi Minh Trail, the wording of trail was really, I mean, it could be, but often it was as wide as like you know, a freeway where they would
Yes,
bend the trees over and
right.
camouflage them. So really, for those guys who were boots on the ground, it was quite a thing, you know.
So when we would fly over the trail, get down really low to try and look under the trees and be able
Wow.
to see it. And the trick is learning how to see things when you're going 500 miles an hour, 500 knots. You look in front of you, and then you let your eyes follow the ground as it goes by, so you're not seeing all the ground. It's like being in your car and focusing on the edge of the roadway. If you just look straight out, then everything's a blur going by.
Yeah.
But if you look forward and you see something like there's let's say it's a part of a tire that's exploded sitting there, you can look at it and you can follow it going this way, and you can get a pretty good vision of it. And so we were doing that at low altitude, flying very fast, and also maneuvering the airplane constantly, because if you flew straight, somebody would just simply, like you were a duck, and aim in front of you and you'd fly into it. Obviously, I didn't duck often enough to come back with holes in the airplane, but they never had any traumatic holes. They were just small holes. Um,
And did you ever have like a SAM lock onto you at all? Because I
oh
know.
yeah,
Oh,
yeah. When we would fly in North Vietnam, we would have SAMs lock onto us, and um, there's a position in the Air Force that's called a flight examiner, and that's a person who will go and take up somebody else, and that person will show them how well they can fly. You know, we used to wear a patch that said SA2 flight examiner, so that we were, just toying with the idea that we were watching these and stuff. Um, the early SAMs, you could get them to commit on you, and you were more maneuverable than they were. They were flying very fast. And so if you're flying along and you see the SAM coming up at you, we would typically push over, start to accelerate. The SAM would start to go down, and then with timing, and sometimes it got a little closer than you'd like, you would pull up, and the SAM's going so fast that it can't make the turn. So it would go underneath you. As soon as it realized it was no longer tracking you, then it would explode. But hopefully, all of the pellets and stuff that was from the explosion would go by you rather than into you. And so I never got hit by any of those, but I've seen one or two.
and just for the people, so they have a better understanding. Did you have a backseater? So a guy who was.
During this time, I was the backseater.
Oh, wow.
Yeah, my initial pilot training slot was like a co-pilot, to the F4. And it turned out that right after I got assigned that, the Air Force decided we're not going to put pilots in the back seat anymore. We're going to put navigators in the back seat.
Okay.
So when I finally got out of the F4, I was the last of 5 pilots who were still in the back seat. And then there were the guys who got that assignment and really wanted to be in the front seat and didn't want to do the job in the back seat. And then there were others, like I think I like to apply to me, but I might be giving myself more credit. I went, okay, I would prefer to be the guy in the front, but I've been assigned the guy in the back. So I want to be the best guy I can be in the back. And so something called situational awareness of you have various locations on the map, and when somebody starts talking about, hey, we've got trouble over here by this location or by that location, in my mind, we didn't have digital maps. We didn't have the ability to draw all of this. We had some paper maps, but sometimes you didn't have everything written on it. But I managed to be able to envision this. And so when this started happening, and they say, you need to go help somebody off of TACAN channel 77 at this bearing and range. In my mind, I could vision this, and I would tell my front seater, turn right to 270. And while he's turning 270, I'll get the map out and do some other stuff. And I'd be within 10 or 15 degrees normally, but I'd get him going in the right direction. And we may have been going east, and now I need him to go to the west. And I knew it enough to be able to get that happening because of what we called SA, or situational awareness. And other things, like I was flying one time on a regular, not a stormy mission, but on a regular mission, and we got struck by lightning. And the lightning caused all of the electrical components in the airplane to fail. And in the F4D, it had a little, well, it almost looks like an office fan that you can pull a handle in the cockpit, and it opens up 2 little doors, and out sticks this fan. And as the air goes by, it spins the fan, and that is driving a generator that supplies power to a few of the essential items in the airplane. Now, some of the things are no longer powered. And my pilot and I, it was night, it was about midnight when this happened, and we're loaded with bombs, but we can't drop them now because all of the gear to drop it, and the thunderstorms and stuff are between us and Da Nang. So now we're going to go over to Thailand, but this was not a fun one because we're trying to fly the airplane, but the airplane without all of it's kind of like when you have a car that has power steering. If the power steering fails, you can still steer the car, but it's much more difficult to do it. And if it has power brakes, and those go out, now you can still stop the car, but you've got to really press on the pedal. And so flying the airplane without some of the bells and whistles that help you do that is heavy and hard. And I remember my my front seater saying to me, I'm sure glad you're a pilot, because we were trading off about every 10 or 15 minutes back and forth because it was so hard to keep the airplane going where it needed to go. The weather was turbulent, and trying to figure out just where we were headed, because all the navigation gear except for the whiskey compass is no longer working. The whiskey compass is the only thing working, and a standby attitude indicator is working, and that's about it. And so in some cases that was good to be a pilot in the back seat, but I know a lot of the guys who didn't do so well because they were upset because they didn't get a front seat assignment. And I just tried to take a lemon and make lemonade. Yeah.
Wow. And now what just as a question, I mean, I've never had the chance to speak to a man that flew in an F4. So if you kind of jet engine stall, can I mean, what do you, or like a flame out? I mean, these terminologies that I've heard. Can you, if your jet engine, if you're flying and it stops, can you try and restart it again? Is it like a restart button?
Yes. Now, in some airplanes, like in a car, Some airplanes carry a starter. Other airplanes use an external source to spin the engine
Okay.
up.
Yeah.
It starts, and then there is no way of spinning it again except for running high-speed air through it. So in the era of the F4, you didn't have a starter that was on the airplane. You had an external starter, and it was usually a great big piece of gear that pumped out hot air, and it went in and it started to spin the engine around. If the engine were to flame out where you're flying, you could dump the nose over and get airspeed so the air going in the intake would spin the engine over and you could start it. The more modern, more efficient engines use a fan. You know, when you look at the size of the engine in an airliner and you see this enormous thing that if somebody stood in the
Yeah.
opening, they could stand up straight in it. Well, those fans are not directly attached to the engine itself, which is buried and much smaller on the inside. And they're more difficult, if sometimes impossible, to do an air start. So they have starters built into them so that they actually can spin it over like your car does. Uh, I don't know if you've ever seen or been around a Formula One racer. You
Yep.
know,
Yep.
it doesn't have its own starter in it. They bring
Yeah.
a big heavy piece of gear, push like a socket in it with an electric motor that
Yeah.
spins up and spins the engine and stuff. And then if that one ever quits, the only way you can start it is if you um, pop the clutch while you're still moving. You might be able to get it going. But if you've come to a complete stop, that engine is just going to sit there until you bring the starter there. So other airplanes, and the SR was one of them, didn't have a starter. It had to have an external unit. And that's a real interesting story just all by itself because the SR's engine was so big that when you think about trying to turn it over, the amount of when an engineer figures out how much force it needs, he says that it takes that much torque. And they were talking about it, and one of the other guys says, "Well, my Buick has about half of that." And they said, "Well, why don't we put two Buick engines together to start it?" And that's when they were figuring out how to get the engine to start the very first time. Um, this is what they used was they took two Buick 401 Wildcat engines, which were the ones that they put in the NASCAR races, put them together on a starting cart, built a transmission that came out of both engines into one shaft, and now that shaft could be raised up into the belly of the engine nacelle, engage a gear, and they would engage a clutch and start spinning, revving up the V8 engines. One lever moved both engines at the same time, and that would slowly start the jet engine spinning. And when I'm looking at my tachometer, and the SR is one of the few airplanes I've ever flown that used a tachometer that read in real revolutions per minute. Most jet engines read in percentage of the maximum RPM, and so you're at 100% or 90% or 50%. We read in real numbers. And so when I got up to 3,000 RPM, which with a 2-to-1 gear ratio to the V8 engines, they were running at 6,000 RPM, which is right at their red line limit. And they didn't have any muffler systems on them.
Oh,
So it was just it was actually a wonderful sound if you're a car nut or a gearhead type person to hear these two engines. Blah, 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 blah. There is an audio tape out there that I had the link to one time, and it lasts about 45 seconds. It probably would mean nothing to anybody else, but to me, it's almost like listening to your child talk. You know, it's just oh, I love this sound kind of thing, and it's out there. You could Google, you know, J58 engine start or Buick engine start for an SR-71, and hear that sound. But that's how you would start the SR-71. Then later on, they figured out a way of having just a huge air tank that they put a lot of pressure in, and they take a single hose and put it to a little impeller that they would put in that same spot, and they would start it. And then if worse came to worse, you could land at some field. And if they had the little start carts that we used for the F4, if you put four of those together, going into like an octopus area that would feed into a unit, and then you could spin that up. But that little adapter wasn't part of the airplane, so that had to be flown out to wherever you were if that's what you were going to use. So we got off on a tangent about start carts, but that is something else
No,
about the
this
SR
is
that's very unique.
yeah. I mean, this is always great, when things do kind of spin off because it often allows the veteran to talk about aspects that you found exciting.
Yeah,
Uh,
later on, the Buicks they literally ran out of these nailhead 401 engines, and so they went to the Chevy 427, and so they used a big block Chevy for it then. And in some of the museums that have SR-71s will also have the start cart, and occasionally for display purposes, the when you open up the louvers on the side of it to look at the engines, they've got chrome valve covers and a
oh,
couple of stuff to make it all look, wonderful and pretty. But they hardly ever used that one. That was the one for show. The other one was just oily and dirty. But oh man, what a wonderful sound when it revved up.
yeah, I'm sure. I'm sure it's like like a guy hearing a Huey helicopter,
Yep.
the same kind of thing. So here's a question for you. When you're flying at upwards to 80,000 feet and you're looking down at the world and you can see the curvature, that's got to be, I mean, the SR I had read was kind of a mixture of a spacecraft slash, airplane because of the heights, great altitudes, and the gear that you guys were wearing. But going back to seeing the curvature of the Earth, that must have been just something out of this world. I mean, you almost were out of this world.
When you're sitting up there and you're looking out, you see a hazy bluish white toward and you're looking at the horizon. You see a hazy white, and then above it, it starts to thin out and gets darker and darker as you look up to where if you look straight up in the daytime, now you have to take your time to let your eyes adapt to it, but you can start to pick out stars and see stars from that. And the horizon is not, it's not a little tiny ball. It's curved, but it's still an enormous thing from one side to the other. You might be seeing a small drop in it, but it's obvious that it's not like when you're sitting. Well, the best thing if you're sitting on a rowboat and you're out on a flat lake or ocean, you see what looks like a straight line all around you.
Yeah.
And when you get high enough, then you start to see the corners of it start to droop off and stuff. It is amazing. And even though we wore the same sort of pressure suits that somebody in space does, one of the questions is, well, did you get astronaut wings? Well, just because you wear the same gear that the astronauts wear, we were not high enough by a large factor. In other words, you have to be about 300,000 feet,
Oh wow.
and we were, the very best. The A-12 was a little bit lighter, so it could fly just a little bit higher. So during the early flight test, the A-12 got up to 95,000 feet. Well, when you think about that, that's still
Yeah.
1/3 of the altitude of being astronaut wings. And then later on, they realized, well, we're playing with nip and tuck here. We're going to restrict you down to 85,000 feet. And that's about the highest altitude that the SR flew as well. If we were flying real fast, we would level off, we would, quote, stop climbing at about 80,000 feet to go into a cruise climb that as you burn down fuel, you got a little higher and a little higher as you went along to where at the end of that hour's worth of travel, you'd be about 85,000 feet. And that was about as high as we went, although I've been higher. I've shoved the power up, tried to climb because I thought I was being shot at. But you have to worry about aerodynamic things. And even when you're flying that fast, airplane wings can stall. And so we had a minimum speed of 300 to 310 knots. And as I got close to that, as I'm looking at my altitude going up, I said, okay, it's time to push the nose back over. You don't want to stall at those altitudes. Even though you're going Mach 3, you can still stall.
So I know that I had read that there was no SR that was lost during, through a combat mission, but there
That's true.
were quite a few that were, accidents. Um,
There
uh,
were a number of losses, 10 or 12. I'd have to go back to my
yeah,
notes to make sure that some of those were lost during doing flight test analysis of stuff. Three of them were lost doing ground testing. In other words, what turned out to be one of the weak links in the airplane was the landing gear and the landing gear struts and the wheels. If you're full of if you're max weight, full of fuel and stuff, and you tried to put on the brakes were just barely able to do the stopping. If you tried to do any more than that, they could overheat. And so when you when you take an airplane off, there's a critical point in there where if something happens at right about the time you're ready to lift off, the pilot has to make a decision in a very short period of time. Do I stop it or do I go? And if he decides to go and he's lost an engine, well, there's certain things he has to do to make sure that the airplane will fly on a single engine. If he decides to stop it, there's certain procedures he has to do in order to get something that weighs as much as it does, going as fast as it's going, to be able to stop. And they were trying to make that analysis of where is that point for the airplane. And eventually they got to where it is actually better for the SR, instead of taking off with a full load of fuel from a safety aspect, to filling it, it would hold 80,000 pounds. So when I'd go out to fly it on most days, the airplane would have 50,000 pounds of fuel in it. I would burn about 5,000 pounds before I got to the break ground point. And so I was not quite half, but call it half full of fuel. And I'd go to a tanker and refuel. Now, there were a few missions that we flew where we had a little bit more fuel than that, where I did not have to go to a tanker, but I could go supersonic and come back again. And if a tanker wasn't available and they were trying to do flight tests, they would fill it up more, accept the risk, and go fly a mission, get the data points they needed, and come back and land. But there's a lot of myths, and one of my windmills that I've till at sometimes is trying to um, uh, correct people who have myths about the airplane. I can almost the airplane isn't black, it's purple or blue or something like that. That's false. The airplane is really black. There was I can show you the documents, the Lockheed documents that show what the color paint is and what you're supposed to paint it with. But there's a rumor that what started all of this mess was one of the model companies building an SR-71 had an overabundance of dark blue paint, and so they put on their instructions airplane should be painted dark blue. They sold and corrected their overstock in model color, but it's perpetuated a myth. The other is that the airplane, which leaks fuel, one, it was not designed to leak fuel. You hear, oh, the airplane was designed to leak fuel, and when you got it up to altitude, it heated up, and it's everything, and it's sealed up. Well, first of all, the airplane was not designed to leak fuel, but because the fuel tanks were the outside skin of the airplane, you had sealant that would go on the panel as you screwed that panel to the ribs and to the stringers and stuff that were there. That sealant would break down as the airplane got hot and expanded and then cold and shrunk, hot and expanded. So when the airplane came out of the factory for the first month, it was dry. Then it started dripping here, dripping there. And the maintenance manuals had, okay, if it's this panel, you're allowed 5 drips per minute. If it's that panel, you might be allowed 60 drips per minute. This panel, no drips per minute, and so on as you go around the whole airplane. And so, yes, toward the toward as the airplane got a little bit further away from coming out of the factory, it would drip more. But when it finally got to where, oh, it's allowed 5 drips per minute, now it's dripping 6 drips per minute there, they would stop. They would put the airplane in the spot. They would either take off that panel or open up the top and have somebody go into the fuel tank and put new sealant in it. And it was a very laborious process to be able to seal it back up again, but it was not designed to leak, but it did leak. The other thing is that because it was designed to leak, then you had to refuel every time. No, we didn't refuel every time because of fuel leaks. We refueled every time because we wanted to take off with lighter fuel. So if anything happened, we would have a better opportunity to be able to stop the airplane or take it off, depending on, because a lighter airplane is easier to get flying than a heavier airplane, and it's also easier to stop. So we didn't have to do that. And the idea that an engineer would design an airplane to leak. And then the other point is that, oh, it got up to altitude and it stopped leaking. Whoever made that assumption? If that airplane was leaking when it was on the ground, that airplane was leaking while we were flying. It's just that that leak, when you carry 80,000 pounds of fuel or 12,000 gallons of fuel, and you're dripping 5 drops per minute of fuel over here, that's the proverbial drop in a bucket. There's nothing that says it stopped leaking when you were at altitude when it was hot. The whole airplane grew about 3 to 4 inches in length, maybe 1 to 2 inches, maybe 1.5 to 2 inches in width. But it didn't cause the tanks to seal up if they were leaking. They still leaked. So, and then there's other myths, and as we talk, maybe I'll be reminded of 1 or 2 and go off on a tirade on you and take more than your time than you really wanted to hear about. But I have several things that when people say this, it's kind of a hot button for me. No, that's not right. And so.
And I guess we should tell people that you often speak to crowds of people about the SR-71. So you've been asked questions by thousands of people. And I'm sure that this is one common thing that okay, now I got to explain to you again, not purple, but black,
Yeah. And I talked to engineering schools, Purdue, I'm trying
museums, right?
Huh?
Museum. There's a flight museum.
We do it in museums, but I also go to schools, to colleges, and engineering colleges, and I will talk about the design of the U-2 and the design of the SR-71 and how it worked and stuff to go to various schools that are particularly strong in aero engineering. And so we Georgia Tech, Purdue, some of the Southern California schools, and have given presentations to their body. And then wherever there's an SR-71 in a museum, a whole group of us will occasionally have what we call a symposium, which is kind of an old outdated term, but we'll all gather there and we'll put on a program where people will talk about various things, and we'll have a guest panel of 5 or 6 guys who will talk at 10 o'clock, and another group will talk at noon, another group will talk at 2 o'clock, and talk a little bit about the airplane and then answer any questions. The next one, in case your listeners are interested, is going to be at McMinnville, Oregon, at the Evergreen Museum, where one of the best displays of an SR-71 in a museum, to include all of the photo gear and stuff. And it's going to be over Father's Day weekend this year.
Oh, that's cool.
Yeah.
So I'm going to throw you a question that I've thrown to every pilot, and this includes family as well. Now, I'm not going to ask you about UFOs, but I'm going to ask you, did you ever see anything that you couldn't explain?
Well, I've seen a few things that got my attention at first, and then later on, I realized what I was looking at. I've never seen anything that ultimately I couldn't explain. But at high altitude, this is both in the U2 and the SR, and you're out flying in the Earth, and it's at nighttime, and the Earth is pretty dark, and you've got lights on the ground, stars in the sky, and it's all looking good. There's a point when the sun starts to rise, and because you're so high above the atmosphere, I think someone said we were at the 96th percentile. In other words, 96% of the atmosphere is below us. We're in the upper 4%. There's not very much that dissipates or diffracts the light. And so there have been three times when I saw something coming up, I saw something, and I thought that I was seeing a forest fire starting, but it turned out to be the sun coming up.
Mm.
But it's because it doesn't come up and give you the twilight, because there's no atmosphere to take light as it's breaking over the horizon and start shining it out to where 30 minutes before the sun's up and 30 minutes after the sun goes down, it's still light enough to be considered, you know, well, people could drive without their lights on, but I hate that. But, you know, people do because they can still see things. And we used to call that term when we were flying to get our night qualification was the field grade officer's time to fly, because you were flying where you could still do something, but technically it was after, quote, dark. But when I saw the sun come up one or two times flying in a U2 and once in an SR, um, uh, I thought that I was a huge forest fire starting someplace, but I'm glad I didn't say something about it to somebody outside of the airplane. But, but the other phenomena that's fairly weird to see is that what we called the terminator. The If you have the sun fairly low in the horizon, there is a place where the earth casts a shadow, and you're either in the sunlight or you're not. And it's not a blended going from one to the other. It is sharp.
Wow.
And you go from day to night, night to day.
Wow.
But when those missions over Murmansk, when I'm heading eastbound and the sun is in the south over here coming across, and you see this line. And most of the times when we see lines where it's light above and dark below, we think of that as the horizon. And if you were to turn the airplane to go parallel to it, you're now 30 degrees of bank, because that line is at about a 30-degree angle. And it's because of where the shadow is of the earth, and it's dark below it and bright above it. And that's a little unusual. But, you know, uh, no little green men on the wings, no airplanes that joined up on me and then sped away from the SR or anything like that. Nothing to that effect.
So we have 10 more minutes here because I'd like to try and keep these to an hour. Are there a couple of your missions that you did that you could talk about? That I like the one that you told me off air.
Oh,
That was pretty wild.
okay, I can repeat that one easily. So um, when we used to fly out of Kadena Air Force Base in Okinawa, Japan, one of our primary um, tasks were to fly by the DMZ of Korea. And we would fly about 3 miles to the south of the DMZ, parallel to it. And sometimes we would start from the east side, go to the west, do a turnaround to get back onto the same course and fly back. And every once in a while, a little further up the coast, if you go along the North Korean border, eventually it touches Russia. And then just a little past that is Vladivostok, which is one of the ice-free ports that Russia has. This one's on the Pacific. And sometimes when we'd fly by the Korean DMZ, we would turn and go up and fly by Vladivostok, also looking in from about 12 miles off to be able to see what could be seen by either our cameras or our radar and collect any electronics information that was being put out by the radars and other things that were going on. But there was this one mission, and I think it's only one of two ever happened, is that I was planned this kind of mission. At the same time, a good friend of mine, another SR-71 pilot, Les Dyer, was scheduled to replace one of the aircraft Kadena with one that was fresh. It had just come out of the maintenance and was ready to fly for a long period of time. And so he was flying. His course was to fly out of Northern California, around up towards Alaska, around the Aleutian Islands, and then by the Kamchatka Peninsula, and then start coming down by Japan. And typically the way these would go to Kadena, but this one was planned so that he would turn just a little bit and fly past Vladivostok, heading south, while I was heading southeast, while I'm heading northeast at the same moment. So we were directly in front of Vladivostok at the same time with two SR-71s about a half mile apart from each other, simply to stimulate the air defense systems that were in the Vladivostok area to see whether or not, if they had a new piece of gear, if they would turn it on, we'd be able to collect information on it or do something else that got them excited, so we would see what they might do when they became excited. And I have to tell you that when we fly at Mach 3, that's pretty fast. But I had dumped a little bit of fuel, and Les had dumped a little bit of fuel so we could see each other. And we were about 1,000 feet in altitude different, and we flew by each other a half mile apart. Looks pretty close when you're going this fast. And a Mach 6 closure rate is something it's indescribable. It just happens so fast. I see him out there, and the next thing I know, he is gone, because it's not just a Mach 3 pass. The combined speed between the two of us at Mach 6 is extremely fast. And then he went and landed, and then I went and landed, both at Kadena, and party that night.
Now, is there a wave of air that if you're flying past them and even half a mile away, I mean, did you feel like a ripple effect, or you're going so fast that it just cut through it?
I don't think the rippling effect of the two airplanes at a half a mile, I didn't feel anything, and I don't think he ever said anything about that. So it's not it wasn't a problem. No.
Wow. Well, I think that we'll end it here. I'm going to end it for the public. So thank you very much for joining me in this hour. And I was really pumped about talking to you, because, like I said, as a kid, having that poster on the wall, it's like, oh my God. Oh. So thank you for doing that. But when I end the video or the interview, don't go anywhere. I want to talk to you for a sec. So thank you very much.
Thank you. I appreciate it very much.
Yeah, that's cool. And I'll put up an ad about the Evergreen museum, right? That's
right.
All right. Thank you, sir.
You're welcome.